On the night of November 1st, 1986, a warehouse at the Sandoz chemical plant on the edge of Basel caught fire. Firefighters flooded the building with water. That water picked up 20 tons of pesticides, fungicides, and mercury compounds stored on the floor and carried everything straight into the Rhine. Within hours, a red toxic plume stretched 400 kilometers downriver through Germany and into the Netherlands. The entire eel population of the river died across that stretch. 500,000 fish were killed in a single night. German authorities stood on the banks and watched. Switzerland had not notified them the spill was coming. No agreement required it. One German newspaper called it the death of a river. They were not wrong, but that is not the most surprising part of this story. The surprising part is what 5 countries decided to do next, and what it actually took to bring a salmon back to Basel. The Rhine had been dying long before Sandoz struck the match. The river runs 1,233 kilometers from the Swiss Alps through Germany, France, and the Netherlands before emptying into the North Sea. For most of recorded European history, it was one of the great salmon rivers on the continent. Atlantic salmon, each weighing up to 35 kilograms, ran the full length of the river every spring to spawn in the cold headwaters of Switzerland and the Black Forest. Tens of thousands made that journey each year. Cities along the banks fed themselves on Rhine salmon for generations. Then came the Industrial Revolution, and everything unraveled at once. Textile mills, chemical plants, and coal operations lined the banks through the 19th and early 20th centuries. Each was discharged directly into the river. Oxygen levels dropped so low that fish suffocated in summer across stretches of 100 kilometers. Heavy dams built for hydroelectric power blocked every migration route upstream. By the 1950s, Atlantic salmon had disappeared from the Rhine entirely. Not reduced, not struggling. Gone. A species that had used this river for millions of years simply stopped appearing. Fisheries scientists stopped counting them because there was nothing left to count. That absence, it turned out, had consequences nobody had fully measured. A river without migratory fish loses its nutrient cycle. Salmon carry ocean nutrients inland with their bodies. They spawn and die in the headwaters, and their carcasses feed the insects, birds, and soil for hundreds of kilometers from the sea. When salmon disappear, the entire system around a river begins to quietly starve. The Rhine's headwater streams in Switzerland, and the Black Forest became cold, clean, and biologically empty. The river looked healthy in photographs. It was not. By 1986, water quality monitoring stations across Germany and the Netherlands recorded concentrations of chlorinated compounds, heavy metals, and agricultural runoff that exceeded safe thresholds for human contact. Swimming was banned across large stretches. Eating fish from the river was a health risk. The cities of Rotterdam and Amsterdam, which draw drinking water from Rhine tributaries, had invested heavily in filtration systems just to make tap water usable. The river was not dying. It had already died. Sandoz just made the death visible. November 1st, 1986, changed the politics of the Rhine overnight. The images traveled across Europe within days. A red river, dead eels floating in windows stretching hundreds of kilometers, fishing boats with empty nets. Switzerland, Germany, France, the Netherlands, and Luxembourg had argued about Rhine pollution for decades without reaching binding agreements. 3 weeks after Sandoz, the 5 governments sat down together in a different mood. The result was the Rhine Action Programme, signed in 1987. Its central target was written into the agreement as a single, measurable promise. Salmon would return to the Rhine by the year 2000. The program had a name: Salmon 2000. Nobody knew if it was possible. The scientific challenge was straightforward to describe and nearly impossible to execute. Atlantic salmon returned to the exact river where they were born to spawn. If no salmon had been born in the Rhine for 40 years, there were no adults to return. The river had lost its founding population entirely. Rebuilding it meant starting from scratch in a river that still had 17 major dams blocking the upstream migration route, in water that was still toxic in sections, in a political system that required 5 sovereign nations to agree on every step. The International Commission for the Protection of the Rhine, the body coordinating the 5-country effort, oversaw the first release of young salmon into the Sieg, a tributary of the Lower Rhine in Germany, in 1988. Young salmon at the migration stage, each roughly the length of a finger, were raised in hatcheries from eggs collected in rivers in Ireland, Scotland, Sweden, and France, where wild populations still existed. Between 1998 and 2009 alone, 1 to 3 million of them were released into Rhine tributaries each year. André Breukelaar, a fish migration researcher at Rijkswaterstaat, the Dutch National Water Authority, built and ran the electronic tracking network that followed those fish across the Rhine Delta from the late 1990s onward. His system used fixed detection stations placed at river junctions across the Netherlands and Germany, each one reading a unique signal from tags implanted in individual fish. Every salmon that passed a station was logged. Every salmon that did not was noticed. The data Breukelaar's network produced became the primary evidence base for how many fish were actually completing the journey, where they were dying, and which dam passages were working. What the data showed was that the river was changing faster than the models predicted. In 1990, 2 years ahead of any scientific projection, the first adult salmon was caught again in the Upper Rhine system. It had navigated the Dutch Delta, climbed the Lower Rhine through Germany, and entered the Sieg to spawn. Then more returned. Detlev Ingendahl, a fisheries researcher who studied natural salmon reproduction in the Sieg tributaries, documented something in 1994 that the program's designers had not dared to schedule as a target: wild-born young salmon, hatched from eggs laid by returning adults in natural gravel beds in the Sieg and its tributary, the Brohl. Not hatchery fish, fish born in the river. The cycle had closed 6 years before the program's deadline. But here is what nobody had written into the program documents as a success metric. In 2012, 2 Atlantic salmon were detected passing through the locks at Basel, Switzerland. That is not a remarkable sentence until you understand the geography. Basel sits near the headwaters of the Rhine, more than 800 kilometers from the river's mouth at the North Sea. To reach Basel, a salmon must navigate the full length of the Lower Rhine through the Netherlands, climb through Germany, past Cologne, Mainz, and Karlsruhe, pass through Alsace in France, and enter Switzerland. Every one of those stretches had been biologically dead within living memory. Everyone had dams with fish passage channels only recently built alongside them. The 2 fish that reached Basel in 2012 had threaded through shipping locks. They had passed under cargo barges in some of the busiest commercial waterways in Europe. Decades of coordinated work across 5 countries. Millions of young fish released every year for 2 decades. A tracking network spanning 2 countries and dozens of detection stations. Fish passage construction at dam after dam across 800 kilometers of river. The measurable outcome in 2012 was 2 fish. That is the correct way to understand what ecological restoration actually costs. What those 2 salmon represented was proof that the mechanism worked end to end. Not that the work was finished, that the entire chain, from hatchery to North Atlantic, to river mouth to Basel, was functioning. When the Rhine's water quality reached the threshold that let those 2 fish complete the full migration, it also meant the water was clean enough to support 63 species of fish across the main channel. A count confirmed and published by the International Commission for the Protection of the Rhine. It meant the small invertebrates, insects, and crustaceans that form the base of the river's food web had recovered enough to feed those 63 species. It meant oxygen levels, temperature, and sediment quality had returned within the range of a functioning river. By 2016, nearly 8,900 adult salmon had returned to the Rhine basin to spawn since the program began. Fish from the Rhine, for the first time in a generation, were again safe to eat. The Sandoz disaster did not save the Rhine, but it created the political conditions under which the Rhine could save itself. Every cooperative framework for cross-border river management built in Europe after 1987 was shaped by what happened on the Rhine. The Danube River Protection Agreement, signed in 1994. The Water Framework Directive adopted by the European Union in 2000, which set binding water quality targets for river systems across the continent. The methods developed on the Rhine, coordinated monitoring, large-scale restocking, fish passage engineering, and enforced discharge limits became the template that other rivers borrowed when they needed recovering. There are still dams on the Rhine. There are still shipping channels, industrial zones, and agricultural runoff entering the tributaries. The river is not what it was before the mills arrived in the 1800s. It is something different now. A functioning ecosystem operating inside an industrial corridor maintained by active management, dependent on ongoing cooperation between governments that could have walked away from each other the morning after Sandoz. The 2 salmon that reached Basel in 2012 did not know any of that. They followed a chemical signal in the water, the faint molecular signature of the river where they were born. They had been following it for 800 kilometers. They passed through the locks at Basel in the dark. What they were doing was not symbolic. It was biological. But it proved something that the scientists and the 5 governments had spent nearly 3 decades trying to prove: that a river people had watched die could carry living things again all the way to its source, that the work was real, that it had worked. In our next video, we travel to the Elbe, where a different kind of collapse unfolded behind the Iron Curtain. Cut off from the international framework that rebuilt the Rhine, and what happened when the wall came down and scientists finally measured what 40 years of unmonitored East German industry had done to one of Central Europe's great waterways. If the Rhine surprised you, the Elbe will stop you cold.